Right, so right now let's jump into question 12. In this diagram, a circle with center O is circumscribed about an isosceles triangle ABC. So what it really means is that I have a triangle ABC, and on each of the vertices, it lies on this circle, on the circumference of the circle. AB equals to AC, so I'm just going to quickly write that down because that tells me that ABC is an isosceles triangle. The radius of the circle is 9 cm. Okay, so if it's center O, that means this must be 9 cm. 9 cm, 9 cm. It's just easier when I write it down on the diagram. Angle BAC is 40 degrees, so we already got that down. Find in radians the angle BOC. So question 1 is simply asking, what is this? At BOC, this angle. It's question 1. Okay, so let's jump right in. Right now, the first thing that comes to mind is that there is a property where it states that the angle at the center it equals to 2 times the angle at the circumference. So if this x, this is 2x. Yep. So that's not the focus of this video. So I think there are other videos that focuses on these properties. So in this case, it really tells me that this is 40 degrees. This must be 80 degrees. So I'm just going to go ahead and write part A. That angle BOC is simply 40 degrees times 2, 80 degrees. But now it says find in radians, so we need to convert that. So I'm just going to do that quickly. I'm going to say degrees to radians. 360 degrees converts to 2 pi radians. Now I want 80 degrees. So to get there, let me get to 1 degree first. 2 pi over 360. And then multiply by 80. 2 pi times 80. Alright, so I can say angle BOC is 2 pi over 360 times 80 radians. So let me simplify that a little bit. So it says leave my answer in terms of pi. So I'm just going to key in the numbers and not pi into the calculator. And now let pi sit at the end. So this gives me 2 times 80 divided by 360, which is 4 over 9 pi radians. 12b says find the area of the sector BOC. So let me just find that BOC, and that is this sector of a circle. Trying to find this area. Okay, and so we already found the angle BOC, so it's no longer a question mark. Right now, it has become 4 over 9 pi radians. So this is actually 4 over 9 pi. And so that simplifies things because we do know that the area of the sector is simply half theta square. So we can say this is half times 4 over 9 pi. And do we know the radius? Yes, 9 cm. Multiplied by 9. Remember my square. And let's key in the numbers and leave the pi at the end because they say leave your answer in terms of pi. And this will be cm square. So that gives me 18 pi cm square. Very neat. Alright, part C. Show that the length of the major arc ABC is 11 pi. So let's look. ABC. Major arc. What does it mean? Because if you look at ABC, we can say ABC, is it this? Or is it this? Well, in this case, actually, it is pretty clear. ABC is referring to this. It's major because this is the longer one. This is shorter. Right? This is longer. So definitely, we are looking at this. A, see, you're looking at this arc length. And so let's just jump right in. Arc length formula. And so radius is 9 cm. What is theta? Oh, now we have to find what this angle is. So let's think about it. If I can find this angle, then I can just add it to the red 4/9 pi to find the yellow angle. And can I find this angle? Well, I see that this is actually an isosceles triangle, and I think that means that this radius here actually splits this 40 degrees into two. So this is 20 degrees, this is 20 degrees, and since this is radius, this is also the radius, so that means this triangle is also an isosceles triangle, right? 9 cm, 9 cm. So that tells me that this also is 20 degrees. So I can say angle AOB is simply 180 degrees minus 20 degrees minus 20 degrees, which is 140 degrees. Now, I have this angle in radians, so I have to convert 140 to radians, and then I can add it both together. So I can say degrees to radians. Once again, just go through the whole drill. This is 1 degree. (140 degrees). Alright, so let me just simplify this so that it looks better. 7 pi over 9. So that tells me this is 140 degrees or 7 pi over 9 radians. Okay, so the yellow angle is therefore 7 pi over 9 plus 4 pi over 9. So this is 7 pi over 9 plus 4 pi over 9, which is basically this 7 pi over 9 plus 4 pi over 9. And that gives me 9 multiplied by 11 pi over 9, and the 9's cancel out, 11 pi. Shown. Well, it's in cm.